All right, so moving on to the last part of this lesson, it's writing formulas of polyatomic and multivalent ionic compounds. So I guess they do this at the end. So 3 things to keep in mind when we're writing the formulas. So we're writing the formulas as opposed to the names. We always need to have the charges of the individual atoms, and they must balance to produce a net charge of 0. So that's one thing to note. Our whole compound should always have a net charge of 0. So the positives should equal the negatives. Polyatomic ions are named according to the table in your data booklet, and I will post that data booklet for you, or that list, so that you can look back on it, but it's also in 5 or 6 slides before this one in the slideshow. Multivalent ions can have more than one possible charge, and you must decide which charge allows the compound to be neutral. So you got to figure out which charge is it that is in that to make it a 0 overall charge in the compound. All right, so let's practice some of these, try them out. They're mixed together, so this is maybe a good way of testing your knowledge on this, because when we put these, or when you're learning these or when you're doing your assignments, they're going to be mixed together, so you might not always know, like, oh, this is molecular covalent, this is ionic compound, this is multivalent compound. So there's lots of things that you need to sort of be able to pick out. But my best trick here is that we always need to look, is there a metal at the very first? And these ones will all be metals because we're dealing with ionic compounds. If something's ionic, it should start with a metal. Once we know it starts with a metal, then we know we're going to have to be working with balancing charges. Okay, so there's always going to be a balancing of charges when we're dealing with something that has a metal. Okay, so calcium hydroxide. Our first job is to write the symbols for this. So let's go to our periodic table and find calcium. Calcium is number 20, and it is Ca. Notice that calcium is in that +2 column, so that's what we're going to write. So when I'm writing this down, I'm writing the symbols, but I'm also writing the charges, because that's going to be important because we're going to need to balance it. Our second thing is hydroxide, and hydroxide, you might spend all day looking at the periodic table. There's nothing on here that's hydroxide. And that's because hydroxide is actually a polyatomic. So we need to go back to this picture. And I think I'll take if I can, a screenshot of that so that we can look at it in a second. But so we're looking for hydroxide here. Hydroxide, you can look through to try and find it. I've found it right here. Hydroxide is OH with a -1 charge. Okay. Oops. So that was actually in our... So hydroxide is OH, and it has a -1 charge. Perfect. Looking at this, it's not balanced. We don't have the same amount of negatives as we do positives. So we've got to do our crossover method, or our whale, or whatever you would like to call it. So we take this -1, this 1, and we put it down here. We take this 2, and we put it down here. This becomes Ca1, which we don't write the 1, and OH2. Okay? Something to note here is that that 2 that we took from the calcium goes behind the H, but it's saying there's 2 OHs, not just 2 H's. This is just saying, oh, there's 2 H's. So that's actually not right. So what we need to do with these is we've got to put brackets around. We've got to say that there's 2 OHs together. Like there's 2 O's and there's 2 H's, not just there's 2 H's and 1 O, all right? So those brackets really tell us where or how many elements of this stuff that we have. All right, so that is how you would do that type of writing of the formula. And that one would be known as a polyatomic because it has that OH, which is from our polyatomic sheet. Let's try the next one. The next one has Roman numerals, so that would be a multivalent. And it tells us, it's actually easier this way because it tells us exactly what the charge of iron is. So if we look up iron, it's Fe, and this Roman numeral is telling us that it has a +2 charge. So we don't have to look at the periodic table. Those are going to tell us right away. Our next thing is chromate, and something I'd like you maybe to remember, maybe this will be an easy way. If it well, no, that doesn't work then. I was going to say, if it doesn't have an "ide" ending, if it has an 8, this is an 8, this is an 8, those are going to be things that are not on the periodic table, okay? Ides are normally the ones that are on the periodic table. These 8s and ites endings, those are going to be ones that you're going to have to find on your polyatomic sheet. So let's go to that polyatomic sheet. I just saved a screenshot of it. We're looking for chromate. So if we look through this list to look for chromate, we should find it. Yes, over here. So chromate is CrO4 with a -2 charge. So I'm going to go CrO4 with a -2 charge. Something you might notice right away, this is where I miss having you guys in class. Remember, we always draw that line down to see it's balanced. Well, one side's -2, one side's +2, so it's actually already balanced. So we don't have to do any crossing over here, we just need to write the element. And the element is FeCrO4, okay? Really important is that in your final answer, you should never have charges. So if I see you having like -2, +2 up there, no, that's wrong. You should never have charges in the your final answer. So your final answer is free of charges. Those charges are just there to help us get to that final answer. The third one is magnesium thiocyanate. And again, I told you that that 8 ending tells us that it is something that could be on the polyatomic sheet and not on the periodic table. But we first need to write down our metal. Our metal is magnesium. Magnesium is number 12 and it's Mg. Magnesium is in the second row of the periodic table, which means it has a 2+ or +2 charge. And then thiocyanate, that's not something you're going to find on the periodic table. It has that 8 ending. So we need to go to that picture that I just had there, which is of our polyatomic sheet. We need to look through this sheet to find thiocyanate, and I find it in the middle here. That's SCN -1. So I'm going to write that SCN -1. Right, so thiocyanate is not balanced with magnesium. Why? Because this is a +2 and this is a -1. So those are not the same balance. So we need to actually do that crossover method. So we take this 1 and we put it down here and we put the 2 down here. Something to remember when we're writing our final answer is that if we are bringing any sort of number down here, that we need to put brackets, because that bracket is going to say there's that many SCNs, not just N's. All right, so Mg, then we bring a 1 down, so there's nothing we need to put right there. SCN, and I'm going to put brackets, and then that's a 2. So we brought this 2 down to there. Okay? If you are having trouble or you get stressed out about these polyatomics, something to remember is you could always just, when in doubt, write brackets. So if you want it in this one, even though you don't put anything, if you put a bracket there, I would be like, well, it's right. So just putting those brackets in maybe every single time will keep it so that when you're balancing, you have the brackets in the right spot. Let's do number 4. It's aluminum acetate. So aluminum is Al on the periodic table. And acetate we can't find on the periodic table because it's an 8. So let's look on for acetate here. We find it in the middle here. It's C2H3O2. C2H3O2. And it says it has a -1 charge. I never looked up what the charge of Al is, but I will right now. I don't have it on this sheet. So let's go to the periodic table. On your periodic table, it's not going to say it, but what I am going to tell you, and I would like you to write it in on your periodic table, is that aluminum always has a +3 charge. So not just, I can write on this, can't I? On this picture. So maybe in the picture, you're going to write +3. So you can write it just in the block, whatever works for you. I can't get rid of those. I can only get rid of what I've wrote so far. So Al is always going to be +3. That's one to remember, but you can just write it on your periodic table. Another one that I'll write in for you that will always be the same is silver is always a +1. And I believe zinc is always a +2. And gold, I think, is always a +2, but I think it might also be a +4, so I won't write that one in. But those are some ones that they're always going to be the same, so you can keep those on your picture, okay? Or not your picture, it's my picture, but you have the actual periodic table, hopefully. So back to this. After all that, I just want you to know aluminum is always going to be +3. So this is not balanced. We do need to do the crossover. So we take this 3, put it down here. Take this 1 and we put it down here. So when we rewrite this, this becomes Al. We're bringing a 1 down, so we don't write that. And then a bracket to put around this. And we're putting that 3 from the aluminum right there. Okay, so that becomes Al and then bracket C2H3O2 with a bracket of 3. Okay, so I hope this is not troubling you a lot. I know it's a lot to remember. We're going through quite a bit in this lesson. Like I said, we spend a lot of time on this chemistry because it's really important that you remember this because this is what we're going to need to move on to the next concept. And the last example here is chromium 3 chloride. Notice this has an "-ide" ending, so it's going to be something you're going to find in the periodic table. Chloride is chlorine. Remember the closest thing there, right? It has that "-ine" ending. It's number 17, and it's in the -1 column. So for our chloride, we're going to write Cl -1. For our chromium, we can look up chromium. It's going to be in that area here. Because it has those Roman numerals, it tells us the charge, but I just want you to know what the symbol is. It's number 24 there, Cr. Okay. So Cr is chromium, and this thing is telling us it's a +3 charge. It's not balanced. We got +3 and -1, so we need to do our crossover. So we take this 1 and we put it down behind chromium, and we take this 3 and we put it down below chloride. So it becomes CrCl3. We don't need to write this 1, but if you wanted to write a 1 there, you can. It's not wrong. It's just, we don't need to write 1s. That's as simple as it is. So if you need to do that crossover and you feel like, oh, I need to write this 1, write it. Doesn't really matter to me. But in the long term, you're not going to need to write those 1s there. All right. So that is balancing of our ionic compounds. And there's quite a bit of questions on this on your assignment, so you can do the rest of the assignment now, not just number 1. And please, like, if you have questions, send me them, and watch this video, watch the other videos that I'll post so that you can understand this as good as you can. All right, be safe and have a good day.